All right, welcome everyone to the second session of Tech Lab Summer Camp C++. Today we are continuing where we left off. So last class we covered data types. Today we're going to be covering data type modifiers. Okay, so these are basically the data type modifiers in C++. How many of you know what is the size of an integer in C++? Like how much space does an integer occupy? Does anybody know that here?
Four bytes.
Yes, that is correct. 4 bits. Yes, 32-bit is also correct. 1 byte is 8 bits. So yes, both are correct. Right. But we keep saying that this it occupies 4 bytes. We've also learned this in school. They have this thing that this data type occupies this many bytes. But what does it really mean? Never understood that video. Does anybody know like how binary works here? How binary numbers are stored?
Yes, I do. They are stored in 0, 1 values.
Right? And so like say is a 0, 1 values, right? So this, if I write that, this is 0 and 1 values, right?
Yes.
What is this number then? Like what does this mean?
101.
Yes, 101. Already revolution.
Okay, that's fine. বলছি না
Uh-huh.
নিজে ভুলে গেছি তার উপর
Fine. Right. So do you know like what number this is? Like if you convert this from binary to decimal, what would happen?
ক্লাস 9 এ শিখেছিলাম কি মনে আছে নাকি এটা
আচ্ছা
9 8
এটা না এখন বলে দি
না আচ্ছা বল
5 perhaps.
Yes, this is indeed 5. Wait, 5?
2 to the power 2 plus 2 to the power 0.
4. Yes, 5. Yes, 5. Right. 5. Okay. See, even I forgot. Right. This is how confusing this is. Okay. So I'll for in story, this isn't really necessary unless you're getting into bit manipulation, which does come later on in C++, not in C++, in competitive programming. But for C++, there are bitwise operators. I'll cover them later on. But for now, I'll just explain how basic binary works. Okay, so binary is like any other number system. Okay, like the decimal number system, right? We all know it. So say if I write 6, 9, that, and in junior classes we did this, like this is a ones place, this is tens place, and then there is hundreds place. So this can be written as like 0, 6, 9 if you want to. Okay, so how do you know that this value means 6, 9? You know that because the decimal system says deci, right? And everyone here knows that deci means 10. So this is the base 10 system. So for ones, this it has a thing associated to it, which is like the base to the power 0. The second place has base to the power 1, and third place has base to the power 2, and it like keeps going on like that. Okay, as you go to the left. So whatever you put in the ones place, this is multiplied to base to the power 0. And then it is added to whatever you put here into base to the power 1, and that keeps going. So
And
here,
at the right side of the decimal, it's 10 to the power minus 1, 10 to the power minus 2, and so on.
Yes. Okay, that is floating point. So
And before the decimal, it's called the fractional part. No, the integer part.
Integer part, yes. Okay, so here you have this. Okay, so 10 to the power, so like 10 to the anything to the power 0 is a 1. You all know that here. Wait, Laksha, is this covered in class 8? I forgot what was done in class 8. Did they have exponents in class 8 like this, like 10 to the power something to the power 0?
I think 9 এ ছিল
9 is below, fine.
না 7 এ ছিল।
ও জানি না মনে নেই
7 8 9 ওই রেঞ্জেই ছিল কিন্তু বছরের শেষের দিকে করিয়েছিল এটা
আচ্ছা, Laksha, do you know that anything to the power 0 is 1?
এক্সপোনেন্টস এর কথা বলছিস নাকি বাইনারি টু ডেসিমাল এর
No, exponents.
Decimal to-
Exponents.
এক্সপোনেন্টস ভাই 6 এও ছিল
So shit, I don't remember. I don't think seriously 6 is
এই
0.
6 ও
No.
আচ্ছা
Array, yes, anything except 0.
আইসিসিবিসির কেসটা ভুলিয়ে যাই
ঠিক আছে
Yes, anything except 0.
চুপ চুপ 0 বেসে কোনো নাম্বার সিস্টেম হবে না little
কি যেটা
point
কষ্ট দেয়।
হ্যাঁ so whatever so basically just know this that if you're not familiar with this that anything apart from 0 to the power 0 is 1 okay any
এইটাকে
positive
ইউজ করে যে মড ফাংশনটাকে মডিউলো ফাংশনটাকে ইউজ করে এই লাস্ট ডিজিট সেকেন্ড লাস্ট ডিজিট ওইগুলোকে এক্সট্রাকশন করা হচ্ছে
হ্যাঁ সেটা
তাই না?
হয় হ্যাঁ সেটা হয় ওটা এখানে না বাট ওটা আছে হ্যাঁ ঠিক তো
হ্যাঁ
ব্যাপারটা হচ্ছে এখানে
নাম্বার চয়েসটা ভালো এক্সপ্লেনেশনের জন্য
হ্যাঁ সেটা বটে Okay, so like whatever there is here, you multiply to that to this number which is there in the units place. So like this number, so 9 is multiplied to 10 to the power 0, which is 1. Okay, so 9 to 10 to the power 0 is equal to 9 because 9 to 1 is 1. Is equal to 9, not 1. I'm forgetting maths. Acha. So 10's place we have 6 and 6 multiplied to 10 to the power 1. So 10 to the power 1 is of course 10, so you get 60, and then you have 0 is multiplied to 10 to the power 100, so 0 into 10 to the power 3, not 100. What am I even saying? So 2 right 2. Oh god. So 0 into 10 to the power 2, anything into 0 is 0, so that is 0. And what you do now is like add these numbers, so like 90 plus 60 plus 0, which is 69. So that is how you get this is as equal to that, right? Okay, I hope everyone understood that here, how decimal system works first.
Yes.
Achha. Anyone any doubts? All right, then I move on to binary now. Achha, Jacob. Now, the number I showed before, 101 or lol, however you want to perceive it. Okay, so the first thing is so now this is a binary, right? Bi means like 2, so this is like base 2 number system basically. So this has 2 to the power 0, 2 to the power 1, 2 to the power 2, right? So now similarly as what we did here, we have 1 into 2 to the power 0, this is 1, and then you have 0 into 2 to the power 1, which is 0, and then we have 1 into 2 to the power 2, which is 1 into 4, which is 4. And now if we add these, we get 5, which is what Reaper said, or no said. This was 5. Okay, and since it's like decimal system, there are 10 digits. That is what the decimal means. Okay, so like the 10 digits of decimal are like
0 to 9.
0 to 9, exactly. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then similarly for binary, you have just 2 digits, which are like 0 and 1. These two are the only digits in binary. Okay, so did everyone understand how like binary works? How you convert from binary to decimal and all that?
Yes.
ডেসিমাল টু বাইনারি কিভাবে করতে হয় ভুলে গেছি
Decimal to binary.
হ্যাঁ
Like decimal to binary would be, you keep adding এখান থেকে till the next most significant byte is less than the number, is more than the number itself, and then you get the most significant byte ওখান থেকে, and then you keep going right and reducing the number accordingly.
একটা এক্সাম্পল দেখিয়ে দেন আরে পুরো মাথা ঘুরে যাচ্ছে এবার এক্সপ্লেনেশন শুনতে
Achha, okay. So, let's say 10. No, not 10. 13. Let's say 13. ঠিক আছে? You have 13. So, conversion of, আমি বলিনি এখনো, ঠিক আছে, but like বলছি. So, 13 like you have 13, right? How would you represent this in decimal? You have 1 and we have 3. This is 10 to the power 0. This is 10 to the power 1. Okay. So now you have the value 13. So for what you do in binary that's now is you take, say, you have 13, right? So say this is our binary number grid. Okay. We have, these are our bits. Okay, these are our bits. This is say 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. That should be more than enough for our purposes right now. Okay, so we want to express 13 in binary. ঠিক আছে? So we have, if we put a 1 here, what is the value of this number now? Take this, imagine this is the binary
One.
number, 1. Okay, so 1 is less than what we want to express. Now we need to keep going till the number which this amounts to is more than the number we want to express. So if we put a 1 here, this is 2. 2 is less than 13. We don't know that. Place a 1 here. This is 4, right? 4 is less than 13. So this also does not work. Then we have 2 to the power 3, which is 8. We put a 1 here, and imagine everything has to be 0. Okay. This is 8, which is less than 13. Still less. Fine. We place 1 here. Now this becomes 2 to the power 4, which is like 16. Okay. 16 is now more than 13. So now we know where we want the zeros to start from, like the infinite zeros towards the left. Like, for a decimal number, if we have 13, 12, if we place zeros here, the value will increase. But if we place zeros here, this does not affect the value because the zeros to the left are ignored. Similarly, for binary as well, zeros to the left are ignored. So
I
if we-
just had a doubt.
yeah, go on.
I just had a doubt. Why are we using the base of the exponent is 2?
Because this is the binary system, right?
Okay.
Binary, there are only
Binary
two.
system
Binary
necessary to
means
use the
2.
base.
Huh? Wait, Adhika was saying-
Binary means 2.
Binary
So
means 2.
Right. So since it's binary, right? And binary only has like 2 digits.
So for that reason,
What?
okay.
You're saying something?
No, I just said okay.
Okay, fine. So take it. Since it's binary only has 2 digits. So you can't place a particular digit. Okay. And this is binary, right? So that is what dictates the base. This is like base 2 numbers are fancifully called binary. Base 10 numbers are fancifully called decimal or like denary numbers. Right. That is how it works. This is like we're writing this in binary, that's why we take bases 2. So now 2 to the power 4 is 16. 16 is more than 13. So we know for a fact that we cannot place this 1 here because that itself will make the number bigger than the number we want to achieve. So we shift this 1 to the right. So we place a 0 here and we make the 1 here. 8. To the point where it is just less than the number we want to attain, or like just less or equal to. Fine. So now this is 2 to the power 3 is 8. Okay. So we have 13. Now, as you saw that these gets added, right? So from 13, we now subtract this number, which is 8. So 13 not equal to minus 8 is 5. Okay. Now we repeat this process. Now we have 5. Fine. 5 is, you see, you place a 1 here. This is 1. 1 is less than 5. Okay. You place a 1 here. This is like what, 2. So 2 is less than 5. Fine. Now we place a 1 here. This is 4. 4 is less than 5. Okay. Now we place 1. Say I put a 1 here. Then this would be 8, right? So 8 is more than 5. So we cannot place that there. So we put it 1 to the right again, which is 4. So we put a 1 here. And then we subtract from 5 the value we just put, which is 4. So we get 1. Fine. Now we can place a 1 here. This is equal to, see, 1 z equal. So this means that we have found that this is where this number will go. This bit has to be like 1. So we put a 1 here, and this is long like 1. So 1 minus 1 is, as you know, 0. So, and we fill up the empty spaces with zeros. So that is why the binary representation of 13 would be 0, 0, 1, 1, 0, 1, or you can ignore these zeros and write it just as like 1, 1, 0, 1. Okay.
Got it.
Sure.
But
there is
যদি
actually a
নাম্বারটা বেশি বড় হয়,
Yes, that is what will come to in storage. That is why I explained all this. Acha, Prithviraj was saying something?
there is actually an easier process of doing it. Like we keep on dividing the number by 2, and then we
dividing
record
it
the
with 2.
remainders.
Right.
And then until the quotient
Remainders.
becomes 0, we keep on recording the remainders, so that becomes the binary.
Right. No, see,
Actually,
see.
ওটাই আমার একটু মনে হচ্ছিল।
हाँ,
কিন্তু এটা টেকনিক্যালি তো মোর অর লেস সেমই হলো।
Yes, it is the case.
Uh-huh.
That is what I'm saying. Because you see, as you increase the powers, now you're like, increasing the value, and that's what you're dividing by. And then you get the remainder and you repeat the process there as well. Okay. This is, I was just explaining, like,
তো সেম থিং জাস্ট ব্যাক ক্যালকুলেশনের মতো এটা
This I was explaining like more visually because that is like more math. It's like less math too. ঠিক আছে conversion you don't have to do এখন in C++ you don't have to manually convert ওরকম করে you don't write algorithms for that ওগুলো রেখা আছে already so comparative programming when you're doing you want to be like fast right so you don't want to write algorithms for everything those are pre-written okay for আপাততের জন্য this is me explaining it visually how it works just skim over it okay but what you said also works with you guys that is correct right okay does anybody have any more questions regarding how binary works, conversion works, and all that? All right. And then there are no. Acha, ठीक আছে. Then I'll ask a question about it. Say I write how to do decimals in binary good sir. No sir, ওটা পরে আসবে. 1 0 1 0 1. Okay, this is a number for now. Okay, now I wanted to answer how many bits does this number have?
Fine.
Yes, this does have 5 bits. And you see, I keep saying bits, right? So what are bits? So you know how in like what we learned, the maths we learned, that has digits. So digits. I don't know if this is like actually true or not. This is my way of remembering stuff. So might help you guys. So take it, you have digits, right? So like, and then you have bits. You have digits. This is a D. D is like for decimal, and like B is for binary. So digits can have values from 0 to 9. Bits can have values from 0 to 1. And binary numbers are just called bits. Okay. So this number has like 5 numbers, right? 5 bits. That's what this is like 5 bits. Fine. Now what would this be in decimal? How would you convert? Anyone apart from Prithviraj and or Avradeep? Both of them know this already. Anyone else? I want to see if you're actually understanding or not. They try, khata pencil niye bosh. ওখানে চাইলে you can write it. It's fine. Adrika.
Could you repeat please? We should convert it to decimal.
Yes, decimal. This is in binary. Convert this to decimal liver.
Maybe 2 raised to 2 raised to 0, 2 raised to something like 2 raised to -1 like that. Can we convert like in that way?
Yes, that is how you'll convert. But what will be the final answer? You do the calculation first. Take your time. It's okay.
Okay.
This is randomly put up numbers. Achha. Let's see.
ঠিক বললাম কি একবার দেখ তো চ্যাট বক্সে লিখেছি তোকে
Yes. Yes.
আচ্ছা
Anyone? Adrika, Avradeep, Laksha, Priyarka. If you like Avradeep send the answer in chat, like personal message to me if you want to. It's fine. If you want, you can. Huh? Okay. Okay.
Just a second, just fine. I'm getting something like minus 39.
Wait, explain your process. Okay.
Sorry.
Explain how you did it.
I just took like from starting from 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to
No.
minus 4, 2 raised to minus 5.
You don't go minus. No. You start from 0 and go upwards.
Yeah, that's what I started from. Like I started from the left side.
No, don't
1.
start from right. Start from right. Like-
Right itself.
This is the same. If why not decimal, you start from 10, 0, 10, 1, 10, 2, like that. This also like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the
Oh, yeah.
power 4, like that.
Then the answer is something like 18.
Okay, explain how you got that. 18. Don't explain your answer always. Okay. Like the process, like how what you thought while doing that, all that helps. Those watching the video later. Okay, so let's do this together then. Fine. I got a lot of answers. We'll explain it now. So we have one in
হ্যাঁ
like
বললি কেন রে ভুলভাল বলেছিলাম আমি
ও ভুল করেছিল
right. There's like 1 into 2 to
ভাই
the power
5 ডিজিট ভেবে 2 টু দ্য পাওয়ার 5 ধরে নিয়েছিলাম
আমি ওটাই
ঠিক
করেছি।
আছে, ভুলে গেছিলাম।
এক্সপ্লেন করতে দে এক্সপ্লেন করতে
Right. Like 1 into 2 to the power 0, right? This is 1. Then we have 2 to the power 1 to 0. This is 0. We're not considering this one. So 2 to the power 2 into 1, it's like 1 to 4, which is 4. And then this is like again ignored, and this is like in 16. So 1 into 16 is,
It's 21.
yes, exactly. This is 21. Right. So start counting from 0, okay? I did the same thing. I
yes do
started
not
one.
count from 1
Yes, do not count from 1. Right. Okay. So people do seem to understand how this works. I need to revise. ঠিক আছে. So we're done with YMD for now. Okay, everyone understands, I think. Laksha, Priyaga, if you have any questions, feel free to ask now. So, fine. Okay, then if you want, you can type in chat as well. Questions if you have any. Anyone. Sure. So wait, still lucky didn't put. Fine. I will continue now. Okay. So as I was saying, the entire reason why I actually explained the binary and stuff, okay, is that sure, as you said, who was that? Who said the int has 4 bytes storage? Acha, yeah, I think. Where is it? Prithviraj and Reaper, right? That's correct. Okay, 32-bit number. So basically, what that means now is that it has basically 32 bits, like 32 numbers of sorts inside it. So like 32 zeros and ones, right? But that isn't the case like with normal links. Basically, it is like, say, it stores numbers like this. ঠিক আছে? So yeah, এরকম ভাবে imagine this has like 32 and counted this. So this is like, imagine this to be 32 numbers, right? So in C++ now, for integers, everyone can see the screen, compiler, right?
Yes.
Right. So this is basically like, a sort of variable, if you want to call it that, like a global constant basically, and it stores the maximum possible value for an integer data type. Okay, these are like stored in C++ by default. So if I run this, this should print out the limit for that. And as you see, this is 2147483 647, something really big number basically. Okay, so now we explained that how integer has 4 bytes, which is like 32 bits, so like 32 numbers. So what do you think is the maximum possible value for an integer? Like, how do you express this as like a power of 2? Anyone get it? बताओ. Reprocess 2 to the power 32 minus 1. Okay. Anyone else? Anyone else? How do you explain it like a power? Okay, Deepak, okay. Anyone how like express the power? Like 2 to the power what would be this number? Anyone? Bolo. Ask. What would be maximum possible value? No one. अच्छा ठीक है. Reprocess. अच्छा हाँ. हाँ?
Will it be 32? 32?
2 to the power 32. अच्छा. Okay, let's see. Hey, that is what we get for 2 to the power 32. This is like 42949672996. Right. And this is what we got for yeah.
Is this because of 32-bit?
Yes, because it is 32-bit exactly. So that is how much space it allocates, and that is how many digits it can store. Okay, but there is one issue here. You see, as you see, this is 214748 something, but this is like 429. This is like not the number. But we said that it still has like 32 bits and all. But how does that line up then? Okay. Does anybody know why that happens? Reaper actually said something else. Didn't try that, but yes, 32. The number is off. Right? It's not that number. Why is that so? Anyone? Avradip, maybe?
কোডটা একটু দেখা যাচ্ছে না
Uh-huh.
কোডটা প্রোগ্রামটা
Uh-huh. बोलो. I'll show 31 में लिखी है. Right. Does this number seem equal to this number? I'll paste this number again. So I write it as 2 to the power 31. Not add the rate to the power 31. 2 to the power 31 equals to eta. Because and this number. Int max equals to eta. Right. So you see any similarity in these numbers or like any difference? Like why is this 3, 8 and the y is 7? Like a difference of 1, nah? You know why that happens? Because this
Odd number?
Because
Difference of even number and odd number?
yes, this is odd and this is even, right? But this is, as you see, like this is basically like 2 to the power 31 is basically int max plus 1. Okay, but like why? See, that is because int max is the maximum possible value an int can store. It does not the number of numbers it stores, because the maximum value is, you see, this minus 1, because in binary, as you said, we start counting from 0, not from 1. Okay, so this means that the numbers in integers can go from 0 to 2147. Whatever this number is, big ass number. I don't remember number. Right. Right. So this, the number of digits in this range is this, the number of numbers in this range, because you start counting from 0, right? 0, 1 would be 2 numbers. So like the last number plus 1 is the number of numbers. Okay, got that, everyone?
Yes.
আচ্ছা, another question.
লাস্ট পার্টটা আরেকবার বল, বুঝলাম না ঠিক কি এটা।
Last part হচ্ছে সিসি, এখানে the maximum int max value, the maximum number an int can store, C++ says that it ends in like 7. Okay, but like 2 to the power 31 ends in 8. Like why is that so?
বিকজ int max হচ্ছে 0 থেকে স্টার্ট হচ্ছে।
হ্যাঁ, exactly তাই বলে। Okay, so But no, that doesn't answer the another question. Which is like, one thing I just skipped over. That is, why do I take 31? I just said that integers are like 32-bit numbers. Ato kore bollam. But like now I put in 31. What is this? Why do I put 31 now? Anyone? People knows. But why? Anyone? Any explanation? Like, you don't need to know. You just need to like, whatever comes to your mind. Why do you think this would happen?
Because it starts with 0.
Okay. Anyone else? What do you think? Why?
Because maybe in C++ the maximum value can only go till 2147.
Okay. Take a anyone else? Don't see any participation from Lakshan, Priya, Guna. If you want, you can type in chat. Don't feel shy. We're all, real chill here. Not like a teacher or anything. Right. Okay, you got 2 answers. Both were the good attempts. Okay. But I'll explain why. Because you see, an int, like an integer, as you know, is different from natural and whole numbers because it goes in the negative direction as well. So this doesn't actually start count from like 0. Okay. This starts count from like a negative number.
বুঝেছি.
Okay. So now, as I said, it has 32 bits, right? So out of those 32 bits, 1 bit is like reserved for the plus and minus sign. Okay. So if that 1 bit is like in one state, then the compiler interprets that number as a positive number. And if it is in the other state, then it interprets it as a negative number. So like one of that like 1 bit is reserved for that purpose. So for the number, there exists only 31 places for the bits to go into. That is why this is like the maximum number you can achieve. And this would happen if all the bits were like 1, 1, 1, 1, 1, 1, 1, 1, 1. Understood that?
Yes.
Yeah, so
Got
okay, so 1 bit is actually not accessible.
Yes. For like normal ints in C++. Take it. Fine. Ever, you see,
Okay.
if we come back to our data type modifiers list, this has long, short, signed, unsigned, and like modifiers for ints. Right. So ekhane, you see there is a thing called signed and unsigned. Right. This means that is there a sign before the number? So signed is basically the default thing we have in C++. Okay. So if I declare, wait, where did my compiler go? This. So like this number, like if you declare an int, by default it is always signed. There is always
Also, this signed is the operator before the number.
yes, like a plus or a minus. Basically it tells you if it's positive or negative. Okay. So you have int by default is signed. Now, if we say we want an unsigned int, okay. Now, what do you think would be the maximum number of numbers an unsigned int can store? What do you think?
সাইন্ড আনসাইন্ডের ব্যাপারটা বুঝলাম না কি হলো কেসটা
আচ্ছা so as I
ওই পজিটিভ নেগেটিভের কথা বলছিস
হ্যাঁ ওকে তো
তাহলে এটা
ডাবল হবে কেন ডাবল হবে
কারণ ওই প্লাস মাইনাসের ওই একটা বিট এখানে চলে আসছে
exactly so that the limit for that would be this. And remember this number from where we put in like 2 to the power 32. See, again there is a difference of that 1 because counting is like 0 is included here, and this is like the number of numbers. 0 is included here, but it is not included. This is like the maximum value. Okay, and see this is like the double. It's a double because 2 into 31 and the like 2 into the 2 to the power 32 and 2 to the power 31. The thing is like 1 is multiplied to 2 once more. That's where it becomes 32. Okay, so that is like the difference between like signed and unsigned int. In an unsigned int, there is no space reserved for the sign, and which is why this cannot store negative numbers. So if I do uint min, which is like the unsigned integer minimum, this is not a Is it? Main C++. Huh. It should be things. Why isn't this a thing? Oh well, I guess they're important because assume it to be 0. It is 0 basically. Okay. Unsigned int is basically like 0. If I remove the int, this should show me the negative number, I hope. Do that please. See, this is like the lower limit of an integer, a signed integer. This is a 31-bit number. So this has like 2 to the power 31. You see this, but here you see there is like the concept of starting from 0 doesn't exist here, because the 0 part is there for the positive one, right? So it is included within the positive part. Get it? Here we are starting the count from -1. That is why it actually the lower limit ends in the 8 number. Fine. All right. Okay. So any doubts on that? Any questions? Anyone? All right. No questions on that. I know today I'm getting a bit too theoretical and all. Okay, this is how data type modifiers are. Okay, I have nothing to do. We'll move on to more interesting stuff sooner. Not this class, maybe, but next class, guaranteed. Okay, I promise. Okay. So we covered signed and unsigned. Fine. Now we have long and short. Right. Who knows what like short does? What could short do?
It stores a shorter value of integer.
Yes. What is the size of that? What do you think? What could it be?
4-bit.
4-bit. The short is done. That's a short. Why there's wait a second. Wait, all right, these are 4 bits. Okay, 4 bits would be a maximum of 2 to the power 3 numbers. This is just 8. Okay, it's not 4 bits, it is 2 bytes. It's like 16-bit, basically. Yes. So like if you have this number 32767, if anyone if you play like Minecraft or something, this might seem familiar. This is what they use, I think. I think the number was 32767. Looks very familiar. Okay. Like that is what it means. So like if I put in 2 to the power it is 16-bit, right? 2 bytes, like 1 byte is 8-bit. Remember this. Okay. So I said this like 2-byte number. A 2-byte number means like 16-bit number, and as I said, anything by default is signed. So this only has like 15 stores for numbers. So this would be like 2 to the power 15. 32768. Okay. Did you understand that? Why is like shorter, so it stores less?
Yes.
Fine. This also has a similarly a min thingy, like short min, right, which is -32768. This is 8 because +1 within the number part, because it starts to -1 instead of 0 for the positive side. Fine. So that was short. Okay. So to declare a short variable, you could just go short number, or like variable name, basically variable name. And here you can assign it any value. It has to be less than or equal to 32767, or more than or equal to -32768. Fine, not that. So you don't have to like, basically it's supposed to be used like this short int, because you're modifying the int. You're supposed to place the modifier before. So like unsigned int name, unsigned, or say signed int something. Right. This is how you're supposed to declare them. But like C++ is this thing that if you don't specify what you're modifying, it assumes it to be like an integer. Okay, so if you just set short and short int, they are the same thing. Same for unsigned, and signed is though like basic just int. You can just set int. instead of writing signed.
These data modifiers, they can't be of character types, character type or any other type other than int, right?
They can be. You can use them for floats and like doubles, I think, or like just double. You can use them with like float and double area, okay, to like make them longer. Fine, but I don't think you can use them for chars. There are different data types for chars.
Oh,
Okay, right. You won't need that, like those, bigger chars are used to store like, weird characters like Hebrew characters which don't fit in the regular ASCII standard. So you won't be needing those like for CPU at least. Fine. But yes, those do exist if that's what you're asking. Okay. You won't even have to use it like, double or float. Like normal double is fine for most cases. You don't need like, that much precision for most problems. Basically what you'll need the most is what I'll be coming to now, which is long. Okay. In Python, basically you can type in like as long as the number you want, and Python will be like, okay, I'll store this number for you. Good. Right. Python doesn't complain. C++, since like way more low level than Python, it complains a lot. And it'll do whatever you ask it to. So say I have been
ডাবল ডিক্লেয়ার করার সময় কি আবার সি প্লাস প্লাস এ ওই 0.0 লাগাতে হয়?
no.
জাভাতে লাগাতে হতো, সেই জন্য জিজ্ঞেস করলাম।
দেখা যাক, let's for now that var is equals to 9. See out var. Let's see this.
এই সবকিছুতেই একটাই নাম্বার কেন, এত ফ্যাসিনেশন কেন এই নাম্বারটার প্রতি?
It doesn't throw an error, no? That's all we're interested in. Don't bother about the number, Ato. Right. Works without decimals, works with decimals. You don't need to bother about that. But no. Fine.
ওকে ওকে
Fine. I get rid of that. Acha. Now what I was saying is C++ will, like in Python, whatever you tell it to do, if it is not something valid, it won't listen to you. It will not do it. Okay, it knows that. Okay, it's like, a strict parent. If it knows that you will mess it up somehow, it won't let you do it. C++ is like, very chill, like them. It'll like, whatever you tell it to do, it will do. It doesn't really think what you're doing is correct or like wrong, or like, it doesn't bother what you're
পাইথন
No, C++. It doesn't bother what you're doing. Like, doesn't think about what you're doing. If you like, I don't know how many actually know what pointers are, but like if you assign a pointer to like someplace else, it'll like, go there and check if there's anything and return a garbage value, as Stella pointed out last time. So if I have say int or like a short, if you will, short num, and we saw the limit for this is 32767, right? So if I like see out num handle, and we get this, right, which is normal, which is expected. Now if we say place an 8 here and run this, what will happen? Or anyone, what do you think will happen if we try to assign a number which is more than the actual limit for the number?
it would give an error probably.
Right, it will give an error. That is what we say. Okay, anyone else? What do you think? I took one answer as it will throw an error. What else? Anyone? Someone note something in chat.
It will not accept the answer, like it will not execute.
It will not execute. Okay. Anyone else? Or could anything? It doesn't have to be correct. You don't have to be correct.
It would probably bring it down to 3 to like whatever the max
like cap
number
the
is.
number. Okay, right. Okay, fine. Okay, good answers. Anyone else? You don't have to be correct always. Okay, it's fine to be wrong. Like a wrong most of the time.
Like it will be invalid.
It will be invalid. Okay, let's see what happens. Chalo, execute करके देखते हैं. Interesting. It became minus.
Why?
I wonder. Why that became minus? That's okay. See, again minus. Right. What if we put in like 9? What happens? It's counting backwards now. Interesting.
So there's a data overflow.
Yes, exactly. This is referred to as integer overflow, or like in this case, short overflow. Okay. Basically, whatever you want to assign to it, it won't give you that. It'll give you some weird ass garbage value. And like this is not really technically not a garbage value since it does have meaning to it. But I won't be going into that. Basically, know this, that if you assign something more than what it can handle, it will just give up and like just give up on you. It'll just give you random as values. It's like when school gives you too much work and you can't complete all that work in time, just rush through it and just do it haphazardly. Like, you don't care about neatness and all. Simply like C++ does that too. If you give it like too much load than what it can handle, it'll just give you like show your attitude and like give you like random values and like run away.
হ্যালো নিজের কথাটা বলে দিবি
সেটা তো বললাম, but হ্যাঁ like explains the thing. ঠিক আছে? So ever say similarly for integers, we saw some like, really big value, 10 to the power 9, I think. Let's say assume it to 10 to the power 9. So 9 digits, then 1 2 3 4 5 6 7 8 9. This is 10. Find this. Okay, no, not that.
এটা পেছন থেকে আবার কাউন্টিং স্টার্ট করছে ক্যাপ করে দিয়েছে তারপরে সেটাকে আবার পেছন থেকে কাউন্টিংটা স্টার্ট করছে তাই তো
Yes, that is what it does. Into like that is very complex, the logic, so you don't need to worry about doing math.
না কমপ্লেক্স কিছু না ভীষণই সহজ
না সেটা তো
আরে-
এখন আমি লাইক অ্যাপ্লিকেশনে বলছি, ইউ উড নেভার ইউজ দিস না, এরকম ভাবে ম্যাথস করবি না কখনো।
হ্যাঁ অ্যাপ্লিকেশন অবভিয়াসলি কোনোদিন করবো না মানে এইভাবে যদি তুই 32767 না ক্যাপটা
হ্যাঁ
তুই 70 ইনপুট করে দেখ
32670।
তাহলে বুঝে যাবি পেছন থেকে তখন একটা -32766 আসছে আই গেস আমার যেটা মনে হচ্ছে দুটো নাম্বার চলে গেছে প্লাস থেকে মাইনাসের ওখানে কনভার্সনে, আরেকটা হচ্ছে ওইখানে মাইনাস থেকে মানে একটা হচ্ছে মাইনাসের কনভার্সনে আর দুটো হচ্ছে 7 আর 6 এর ওই জায়গাটাতে
32670 এরকম দেবো।
32770 6 না 32770
আচ্ছা
সেমিকোলনটা দে
রাইট ওকে হ্যাঁ interesting. Ignore this one now. Right, this is basically the thing is I'll just comment this option now. No, what are you doing, C++? Oh, sure. Thanks. It does loop back, yes, you are correct, honey. ঠিক আছে, so you don't need to like bother or maybe you won't learn using logic, but like that is what happens if you want to know.
হ্যাঁ
So
এগুলো নিয়ে মাথা খাওয়াতে গেলে মরে যাবো পুরো অ্যাকচুয়াল প্রোগ্রামের সময়
সেটাই তাই বলিনি তো int নাম এরকম আছে। So now this is way more than what an int can handle, I believe. So okay, no, damn, C++, good job. Increase the load then. Right, there we go. We have hit integer overflow. You see that value, what logic that you used for shorts, that I guess would apply here, probably would, but as you can see when you're dealing with big numbers, they don't really stick to limits ওরকম করে, তো এরকম garbage values আজেবাজে number আসতে থাকবে। ঠিক আছে, so the number will be same.
So is there anything like try catch thing here so we can prevent the application from crashing?
See, what I said, right? Python will Python is strict parent, C++ is chill parent. This won't crash. This is not crashing. This is warning us. Okay.
Oh.
This is not throwing errors, right? So if you were to put a try catch, this wouldn't detect it or you know, do that on your own. Fine. So this is like overflowing clearly. So for what you do in Python is Python doesn't, I don't think it stores numbers এরকম করে, it stores them in strings maybe. I'm not sure about that. It might be the case. Okay, you can, this is another thing, you can store string like numbers in strings and then parse them on your own to handle bigger numbers like without integers or like that, but that is very advanced for now. I won't be going into any of that, but that is something you can, if you want, you can research on.
ভাই এই পার্স ওয়ার্ডটা ইউজ করলি, এটা চেনা চেনা মনে হলো কিন্তু কি কোথায় ইউজ ছিল ভুলে গেছি জাভাতে। ইন্টিজার ডট পার্সেন্ট এরকম কিছু একটা ছিল।
পার্সেন্ট হচ্ছে স্ট্রিং থেকে ইন্টিজারে কনভার্ট করার জন্য। পার্সিং মানে হচ্ছে ইউ স্ক্যান সামথিং এন্ড কনভার্ট ইট টু সামথিং এলস।
আচ্ছা, এটা ইনপুট নেওয়ার সময় ইউজ হতো।
হ্যাঁ,
জাভাতে এটা ইনপুট নেওয়ার সময় ইউজ হতো।
হতে পারে।
JavaScript এও আছে পার্সেন্ট।
আচ্ছা, আদিকা গো।
জাভাস্ক্রিপ্ট আমি জানি না, আমি জাভাটাও জানি।
Wait. Adhika, you're saying? Your voice is breaking, Adhika.
Yeah, I'm trying to say is the result which is shown over here is -539 so on. So is it something related to the long?
Yes, that is what I'm
Long
coming to. Yes. This is not related to long, but that is what I'm going to explain now. Acha. So you see, long basically, there is long, which basically doubles the thing, like the bytes allocated to it. So like an integer is like 4-byte number, which is like 32 bits. So like a long would be like 64 bits. Okay. So what you can do is put say long int. Okay. And if I run that now, see, big number represented properly, no errors. Fine. Okay. Right. This is how you store bigger numbers in C++.
What is the maximum extent of long?
Yes, wait, I'll show you. And basically, you can stack longs. Okay, so as I said, long int. You can also write long int. Fine. Both are valid. They are supposed to be different now. Okay, I'm not sure about this one. This is like uncharted territory for me as well. So long is supposed to like ints. Okay, ints by traditionally in C++, they can have either like 2 bytes or like 4 bytes. Okay, whenever you put like okay, no way, no. Okay, I don't know. They probably made some version changes. I mean, like, gone through documents for ages. So basically, what you have to know is like long and long, they have the same limits. So I'll demonstrate that for you right now. So if you have long int, this is basically the global constant for long. No, long max. What am I saying today? Oh God. Max. Right. That is the extent of long. Big number. Right. And if we say do that here, we have 2 to the power 63, I guess. See, the number is similar. 9.2233720, 9.2233720, and then it doesn't actually show the entire thing properly.
Into 10 to the power 18.
18. Fine. So what basically this means is like you can store like 18 digits. Imagine that, because in like normal C++ problems, you won't have numbers like this specific, like 9 point this. The limits given to you in C++ in like competitive programming, which we'll soon do later on, is like 10 to the power 9, 10 to the power 18. Okay, so like remember that whenever it's like 10 to the power 9, that means it's an integer. When it's 10 to the power 18, it's you're long. Fine. Not that everyone. But this is like a 64-bit number. That's why we use 63 here, because I said signed and unsigned. I can put a U before it. This basically, why is caps lock on? Unsigned long, this will be like double the thing. See, 18. Oh yeah. Fine. Now there is another thing called long. Okay, it's like that, like long max basically. Now this has the same limit as long, right? I don't know why that's the case. That should not be the case, technically, because there is like a separation between them. But since this is what C++ is giving you, you just take what C++ gives you happily. You don't complain with C++. Fine. So you have long max, which basically stores. You don't bother about long now. Long max, which like long, which basically stores 10 to the power 18. Okay, or like 2 to the power 63 of these store korte pare. Alright, got that everyone?
Yes.
Right. That those are data type modifiers. So to denote like a long int, just type that var is equals to some big number and something really big. We'll be able to show that. Let's see out there. Fine. Okay. I think stores that probably doesn't overflow or anything. And this you can also write as like long var. I think should be able to. Works. The int is like assumed to be there if you don't put it in there. It's like short way of writing long int. Fine. So that covers all our data type modifiers. Fine. Now, does anybody have any questions on data type modifiers? Anyone?
No question.
All right. Nice. Good. Okay, then. Chalo, next slide. We have type conversion. Okay. This is what we faced last class for a while with bools, how truthy values, falsy values, all that. This is what we'll be covering now properly. We have in C++, just like most other languages, we have two types of type conversion. Okay, implicit and explicit. What these mean is like implicit is just assumed type conversion. C++ does it for you. The compiler assumes what you're trying to say. And explicit type conversion is very specifically tell the compiler to do a certain thing, do a certain conversion. Fine. So I'll show you examples. First, we have implicit type conversion. This is like a chart for implicit type conversion data loss. I'll explain that. So basically, say we have, a float num is equals to 69.420. Okay. Now imagine you want to round this off. Okay, you don't want the decimal. You don't like the decimal, right? You hate decimals. You want to get rid of the decimals. So what you can do is you can type int num int is equals to num. Then you see out num int. Okay. Now what do you think this would like? Print? I'll explain, but like, what do you think?
It would round
As
off.
expected 69. Round off হবে না, just a decimal টা কাটল হয়ে যাবে।
Right.
Oh,
Okay. Adrika?
Decimal?
Round off হবে না এটা।
Right. Then on this. See?
আবার একই নাম্বার।
Right. So as you see, there is data loss here because you lose the floating thingy. And if you look at our chart here, see we are converting from float to integer. Okay. And as you go down, there is data loss. And as you go up, there is no data loss. So if I were to convert like 69, say 13 as number, and I want to convert it to a float. So num float, this is like float is equals to num. Then I change this back to int. So right, num float. So what would this print?
0.00 it would add, I think.
0.00. Okay. Anyone else? Let's see. This print 13. Right. What you said, right? Yeah, Prithviraj. By default, I don't think C++ adds extra decimals. You can set it later on using count arguments, but that will come to later. Fine. Other languages do that. Yes, if it's a float, it does print the external 0.00, and then you have to format it if you want less or more zeros, like that. Right, but C++ doesn't do that.
Higher data type থেকে lower data type এ conversion এর সময় ওটা তো round off তো হয় না, just decimal টা কাটল হয়ে যায়।
Data loss.
মানে তুই যেখানে 69.420 যেখানে এন্টার করলি সেটার বদলে যদি তুই 69.96 ও দিতিস তাহলে ওটা 69 ই করতো, তাই না?
There is data loss, like
কিন্তু রাউন্ড অফ করলে ওটা 70 হয়ে যায়।
round off করবে না
রাউন্ড অফ করবে না ওটা।
Yes. Even if I enter something like 999, It's still 69, not 70. It doesn't round up. Just ignores it because it can't handle OTA. As I said, I explained it, bytes. Like there is a limited storage for everything, so it cannot handle all that. Just ignores it. Fine. So have a long double thick if we convert to an int, there would be data loss. If it's like a big enough number, it won't be able to handle it, and it would overflow, as we showed last time. Right, when we try to store a big number to a small, like a short data type, or to an integer, a bigger number, it would like overflow and show like negative values and weird values. You don't want any of that. So usually you try to convert from a lower to like a higher data type, but in certain cases, like say to remove floating point numbers, you can convert from float or double to integers, or long or short, or for like ASCII conversions, you can also use integers to chars and all that. Fine, we'll come to that later on. That is part of explicit conversion now. You can also do that, implicitly. So who here knows the ASCII table probably? Like somewhat of the ASCII table. Welcome to our ASCII table is. But who knows?
capital A to capital Z, small a to small z, ওইটার কথা বলছিস?
Yes. What is
ওইটার উপর বেস করা তো এই তোর বোনাস কোশ্চেনটা ছিল।
Exactly. That is what we wanted you to research into. Fine. What is value for capital A or like small a in A?
Small a তো 97 আর capital A 65.
Right. So here, as you see, you have integer number.
এটা রিসার্চ করা কিছু নেই, যে একটু হলেও কোডিং করেছে, প্রোগ্রামিং করেছে, সে জানবেই।
হ্যাঁ। Like এখানে we assume no one has any programming experience, ঠিক আছে? তো তাই বলে খুব বেসিক, ঠিক আছে? তো int char এরকম কিছু একটা we make, and we assign this a value num, and then we see out char, not char, int char. Fine. What would this print? Bolo. Let's run this. Fine. See, small a. Why does this happen? Because
it converts to ASCII.
Exactly. Converts it to a character. What the character knows and like interprets it as. So similarly,
এটাও implicit conversion হচ্ছে, তো explicit কোনটা?
Explicit আসছি। ঠিক আছে, I'll show you ASCII table. ASCII table is something which you should go over at least once, maybe sometime. You don't need to memorize all of it. That is very unnecessary, but it's good to go over it at least once.
আমাদের তো মনে হচ্ছে সিলেবাসে আছে 11 এ।
11 এ আছে, first chapter এটাই I think. আচ্ছা, so this is basically all. You don't need to know about all of these things mainly. Maybe 0 to 9, how that works, A to Z, and A to this small a to small z. Okay, yeah, like you just need to start the know the starting values, and then you can add 26 and get the ending values like that. 26 minus 1 because first is included, all that. So what you basically need to do is this, like 48 is 0, 65 is capital A, 97 is small a, right? I'll be sending this image, copy image. I'll put this in resources in the CP channel, so you can refer to it later on if you want to. Fine. That was ASCII table and like implicit conversions for now. Next we'll be moving on to what over the past. Explicit type conversion. Okay, now C++ has two types of explicit type conversion. And this is because you see C++ is actually backwards compatible. So you can actually write C code in C++ and the compiler would understand what you're trying to say. So there is C style conversion and there is the C++ functional conversion. I'll show you the difference between both of them. So say, wait, that is the wrong browser, right? I have something like float 69. With the previous example, this float FLT is equal, not flat, FLT is equals to this, and then we type say C out, and now we type FLT. We don't want to use extra variable or something, and what we want to remove the decimal part from A. So what we do for that is we have to explicitly tell the compiler that we don't want it as a float, we want it as an integer, because as I told you, that removes the decimal part. So what C style conversion looks like is this. you place a bracket, like a square set of round brackets before the variable, and you put the data type you want that converted to inside it. So if I run that runs 69. Okay, this is the C style conversion. This is very weird looking and doesn't, go with the entire C++ theme. So what we do is we use the functional conversion, which is basically like you see main function, we call it a function. A function is basically the name of the function followed by round brackets with an argument inside. So here what we do is, I'll cover functions later on in full detail. Don't worry about that now. But basically you put an int and then you put brackets, and whatever you put inside the bracket, that will get converted to whatever data type you want. So if I run this becomes say 69. If I were to make this 97 and change this to char, that would print in. Because you see, as I said, float to going back to the start.
Data losses.
Right, exactly. So removing data, like when we reach to int, we get rid of the decimal, and as we reach to char, it becomes a character instead of a number. Fine. Everyone understood that?
Yes.
Achha. And this also works for your long double anything. Just put the name of the variable, name of the data type, and then brackets. That is explicit type conversion. Achha. Yeah, how much time do we have left? Just 13 minutes. अच्छा ठीक है सर 14 मिनट होना चाहिए हो जाएगा आज के जा कॉल करा चला हो जाएगा अच्छा explicit type conversion, basically the example I just gave you, that what with comments and stuff. Fine. Hey, this is something we should have covered last class and forgot, but don't worry about it. We'll do it now. This is additional flow control. This is becoming now, the theoretical part is over. So like we have here something, no more Kaif conversions and all that. Right, now back to loops. So, see, you have break and continue. These are used a lot when dealing with loops. So say I have a code like this way. So in
Adjustment, can we like continue the next day?
Acha, it go. I'll continue this till like 9:30. Okay, if you want, you can leave. I'll upload the recording today or tomorrow morning. You can like watch the rest later on maybe. Okay. If you want, if you can stay till 9:30, then do stay. But like if it's the problem, then just watch recording.
Okay.
Okay. Right. So say we have int I is equals to 0. Fine. And then we do while I not equal to 10. We run, we print out I. We do I is equal to I plus equal to 1. Or like I is equal to I plus 1. And then say we do if I is equals to 6, then we break. Great. Now what do you think this will output? What do you think? Any guesses? Anyone?
0, 1, 2, 3, 4, 5.
Acha. Okay. Adrika?
I think so it will be 1. Like
One.
first it will be 0, then it will be 1.
Right. Then?
That's all I think.
Acha. Okay. Let's see. Acha. 0, 1, 2, 3, 4, 5. Okay. Now question is, why does this happen? Fine. We start with I is 1. Okay. Next, when this loop starts, it checks if I is not equal to 10, which is true. So it runs, prints out 0, as you see, and then it goes here. Here, you see, it does I equals to I plus 1. So I becomes 1 because 0 plus 1 is 1. And then it checks if I is equal to 6. I is not equal to 6, so it does not run the break statement and then goes on. And this loop keeps running, okay. And it goes from 1, 2, 3, 4, 5. And after it prints 5, okay. I becomes I equals to I plus 1, 6. Now I is equal to 6, so this statement runs. This statement runs. Break. What break does is it stops the loop in which it is called. So it just exits the loop. So even if I put something like cout, something like the icon is fun. Right. See, it doesn't print that because it doesn't execute anything after it. It will just exit the loop and go to here. If I put
So
in
it's basically like ending the program.
ending the loop, not the program.
Yeah.
Right. So if I put that there,
নেস্টেড লুপ থাকলে ইনার লুপটা ব্রেক হবে, তাই তো?
in a loop না যে কোনো loop you call it in. মানে হ্যাঁ দুটোর মধ্যে থাকলে সেকেন্ডটার ভিতরে থাকলে সেকেন্ডটা বন্ধ হয়ে যাবে।
হ্যাঁ আমি সেটাই বলছি, সেকেন্ডের ভেতরে থাকলে সেকেন্ডটা ক্লোজ হয়ে যাবে, তাই তো?
Yes. Whichever loop you call it in, that will exit. So say C plus is fun. This executes because after this it goes to here, like after this, yeah, after the loop. So it prints this and then returns. And then it basically exits from here. Fine. Doesn't end the program, ends the loop. Now we have continue. So say I have something like while
প্রোগ্রাম এন্ড করার জন্য তো এন্ড বলে একটা কমান্ড আছে নাকি?
না program end করার জন্য you return the main function C++. Like
জাভাতে একটা ছিল এন্ড বলে, সেটাতে প্রোগ্রামটা এন্ড হয়ে যেত।
Python, C++ maybe আছে, but like usually all you do is like go back to main function scope and then just return. ঠিক আছে হতে পারে জাভাতে, I'm not know অত proficiently Java, Stella জানে Java. That's right. If I say I do something like if I not equal to 6 or 5, something like 5 works. To continue. Yeah. I. And then এখানে I put break. Fine. What would this do if I run this? What would this print? বলো আবরে পরে বলবি আগে আদ্রিকা বল।
I think so. It will be maybe
Try.
0, 1, 2, 3, 4, 5, and then C++ is fun.
So like 0 to 6 and then C++ is 1. Right?
Yeah.
Achha,
Yeah.
Okay. And what about here? Avradi?
ট্রু বলতে কি? while true?
While true মানে হচ্ছে see if I put এরকম কিছু একটা I is equal to I, ঠিক আছে এটা তো সবসময় ট্রু হবে।
হ্যাঁ।
তো অপারেটরটা কি রিটার্ন করে? ইট রিটার্নস একটা বুলিয়ান ভ্যালু। তো এখানে আমি রিটার্ন না করে আমি ডাইরেক্টলি বুলিয়ান ভ্যালুটা বসিয়েছি while true।
আচ্ছা
হ্যাঁ তো what would this print about? 0 C++ is 1। আচ্ছা ওকে রিপোর্ট বলছে। আচ্ছা অবরদীপ বলো কি হবে? Guess, just guess. Just সবাই just দেখতে চাই কি মনে হচ্ছে। এক্সপেরিমেন্ট আমি তো করবো। বলো না আন্দাজে কিছু একটা বলে দেবে হয়ে যাবে, কারণ not be correct সব সময়। What do you feel হবে?
কম্পাইলেশন এরর হবে মনে হচ্ছে।
ঠিক আছে দেখা যাক। Interesting.
আচ্ছা
Why does this happen?
আচ্ছা প্রিন্ট করার পরে কন্টিনিউ হচ্ছে না? হ্যাঁ প্রিন্ট করার পরে কন্টিনিউ হচ্ছে, ওইটা আমি ভুলে গেছিলাম।
made a mistake here actually.
জেনারেলি লোকে প্রিন্ট করার আগে কন্টিনিউ লাগায়।
আমি এখানে অ্যাড করতে হতো।
হ্যাঁ সেই জন্য ওটা ইনক্রিমেন্ট হয়নি, সেটা বাদ দে, সেটা ইররিলেভেন্ট আমার জন্য।
For C++ is fun. ঠিক আছে now question is why does this happen? Fine. This happens because you see it starts from 0. Okay, while true means the loop will keep running until and unless I break it or something happens which causes it to stop. The loop itself will never stop because you see true is like a boolean value which is always true because it's true, right? So it will keep running always. So now it checks if I is not equal to 5, I is 0, which is not equal to 5. ठीक है print कर देगा 0 and then increases I by 1, so I becomes 1 now, and then it continues What continue means is it does not execute the loop any further. It does not execute the break statement. If I were to print something like cout ends here and this wouldn't run every time. So run at the end. Okay, so explain why. So one holo, okay, fine. আবার শুরু হলো লুপটা ট্রু
একটা কথা বল,
হ্যাঁ
ধর তুই এখানে ইনক্রিমেন্ট অপারেটরটা দিলি না,
এটা
আর প্রিন্ট স্টেটমেন্ট ওই আইটা যে প্রিন্ট করলি সেটাও দিচ্ছিস না,
হ্যাঁ
তখন এটা কি করবে? ওটা তো কম্পাইলেশন এররই টেকনিক্যালি হবে, ইনফাইনাইটলি চলবে ওটা।
হ্যাঁ হ্যাঁ ইনফিনিট লুপ হয়ে যাবে।
হ্যাঁ,
আচ্ছা তো এখানে
যেমন ওই জিরোর ক্ষেত্রে হলো।
হ্যাঁ 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 এখানে বন্ধ করে দেয় একটা টাইমের জন্য, অনলাইন আইডি তো মানে ওরকম ঘাপটা করা যায় না, তাই বলি। ঠিক আছে,
টাইমার দেওয়া যায়?
না টাইমার দেওয়া যায় না, মানে এটা তো অনলাইন আইডি, সো ওরা একটা পয়েন্টের দিয়ে আউটপুটটা যদি ওটা চেয়ে বড় হয়ে যায় ট্রানকেট করে প্রোগ্রামটাকে এক্সিট করে দেয়।
আচ্ছা,
যাতে মানে ওদের রিসোর্সেস বেশি ওয়েস্ট না হয় কারো ভুলের জন্য।
হ্যাঁ
তো এখানে see I1 হলো as I said like after this and then it continues goes back to the beginning. I1 is not equal to 5, আবার 1 প্রিন্ট করলো, I2 হয়ে গেল, আবার continue means go back to beginning of loop, ঠিক আছে, whichever loop it's called in. তো আবার এখানে গেল and then I again became 2, মানে 1 2টা প্রিন্ট হলো and then 3 হয়ে গেল, 3 হয়ে আবার এখানে গেল, keeps going and then I like 4টা যখন প্রিন্ট হলো আইটা, after that plus হয়ে এটা 5 হয়ে গেল, after 5 it continues, goes here, checks 5 not equal to 5, which is false, right, because 5 is equal to 5. Then we go down here, like if statement run হলো না, like এই পার্টটা রান হলো না, তাই এখানে গেল, এখানে you see count ends here, এটা প্রিন্ট করলো ends here টা and then ব্রেক করে দিল, এর জন্য like লুপটা স্টপ হয়ে গেল and then C++ করে বন্ধ হয়ে গেল। সমঝা? Adrika disconnect হয়ে গেছিল। Adrika, could you hear what I said? No, did you get disconnected? Sure. Fine. Adrika, did you understand this or should I go over it again? Maybe explain again.
Yeah, I understood this.
Fine. Okay. So, I wanted to do go-to as well today. Since go-to অনেকে নেই আজকে, বেশি নেই, so I guess I'll continue with go-to tomorrow. Fine. So আপাততের জন্য
তুই কোয়েশ্চেন অফ দ্য ডে গুলো ডিসকাস কর।
right, I forgot. Right, question of the day. I'll stop recording এখানে. So that was it for today. I'll continue like with go-to from the next class. Right. Thank you and goodbye.